Good morning, students. So, today's session we are going to start with force system or system of forces. Say force, it's a vector quantity, and to specify a force, we require its magnitude, direction, and point of application. When several forces are acting on a body, then it is called a force system or system of forces. So, when all the forces acting on a body are lying in the same plane, when all the forces are acting in the same plane, we call them coplanar forces. These coplanar forces can be categorized into three categories. One, collinear. Collinear means all the forces are acting in the same line. Say there are three forces F1 and another force, say F2, and another force, say F3. If all the three are acting along the same line, or any number of forces, if the forces are acting along the same line, we call it as collinear. And second category is concurrent. Concurrent forces. Concurrent forces means, say this is force F1, this is another force F2, and then another force F3. All the three forces, there is a common point, meeting point, or the line of action of the various forces meet at one single point, that is called concurrent forces. And the third one is, say one force F1 is acting like this, another force F2 in some other direction, and F3 say some other direction, F4 some other direction. So these forces, the lines of actions, they do not meet at one single point, and that the third category, non-concurrent. So if all the forces are acting in the same plane, they are coplanar forces, and the coplanar forces is in three categories: collinear forces, concurrent forces, and non-concurrent forces. Now we are going to discuss in today's class about concurrent coplanar forces. So we are going to discuss concurrent coplanar forces. So when several forces are acting in the same plane and the common point where they intersect or the line of action meet at a single point, they are concurrent coplanar forces. So several forces, the effect of the same several forces has to be made as one single force. So the several forces has to be combined together so that that single force will produce the same effect as that of the several forces, and that process is called composition. Composition of forces, and that is several forces will be combined together or they will be converted as a single force which will produce the same effect as the several forces, and that is called composition of forces. And the one single force which is obtained is called the resultant. Now we are going to study now how to find out the resultant of concurrent coplanar forces. Say that is at a single point, one force will be acting like this, another force say F2, say another force in some other direction. Say there are several forces acting at a single point O. We have to find out the resultant of F1, F2, F3 and F4. That means replace all these with a single force which will produce the same effect as the combined effect of all these forces. So before proceeding to the process of composition, what we have to do is, first step, we call it as resolution. Resolution is, see, each of these forces, say for example force F1, say this force F, I take it, say a force F. This is the x coordinate direction, this is the y coordinate direction. This force is inclined at an angle theta with x axis. That force has to be split up into components along this x direction and y direction, because different forces are having different inclinations. All those forces has to be brought to the same reference plane. So the first force F1, it has to be brought into this x and y direction, or it has to be split up into components. That process is called resolving, resolution, or resolve the force F into x and y direction. So how to do the resolution? The most important topic in statics is resolution of forces. If you know to resolve the forces correctly, then the remaining process is very simple. So the force F inclined at an angle theta. So this component of this force along this direction, this is called F suffix x, and the component of this force along this y direction is called F suffix y. So x component Fx and y component Fy. What is Fx? Looking into this figure, Fx is, what is cos theta? You see what is cos theta? Definition of cos theta is adjacent side divided by hypotenuse. So cos theta is equal to Fx divided by F. Therefore Fx, the horizontal component of F along x direction, that is equal to F cos theta. So the horizontal component of F along the x direction is F cos theta. Then what about this y component? If this is theta, this is also theta. So looking into this, sin theta is equal to opposite side divided by hypotenuse. Therefore Fy is equal to F sin theta. So hereafter we can remember this. A force F, the two resolved components are Fx along the x direction, Fy along the y direction, and Fx is equal to F cos theta, provided theta is the angle of the force with x direction. That is very important. If theta is the angle with the x direction, Fx is equal to F cos theta and Fy is equal to F sin theta. So these are the magnitude. So force is a vector quantity, so you should specify the direction also, only then that will be complete. So what about the direction of Fx? For that, see, from this point O, this force F is acting outward or away from O. So this component will also be, Fx will be away from O or outward. This is the direction. Fy, the force is away from O or outward. So the direction of Fy will also be outward, away from O. So the direction of Fx is towards right, Fy is towards up. Okay. So that is the process of resolution, and we shall discuss one or two examples to make it more clear. Let me illustrate how to resolve this force 10 Newton. This force 10 Newton is inclined at an angle of 30 degrees with x-axis. So, first of all, I will mark the direction. Okay. This force 10 Newton is acting away from O or outward from O. So, the component, this component should be outward. Similarly, this component should also be outward. So these are the directions of Fx and Fy. Okay, the force is acting away from O, 10 Newton, outward from O. So the direction of the components are outward from O or away from O, Fx, away from O, outward, Fy. These are the directions. What about the numerical value? The angle with x-axis is 30 degrees. So this is equal to F cos 30 or 10 cos 30 degree. This will be sine 10 sine 30. So the resolved components of this is 10 cos 30 towards right, 10 sine 30 upward. Let us have another one, example 2. So this is example 1. I will consider another case. Say force 15 Newton. It is at 40 degrees. So a force 15 Newton. This is the direction. What are the resolved components? First we have to mark the direction. 15 Newton is acting towards O or inward. So the two components has to be towards O, inward. Towards O, towards O. So this is Fx, x component. This is y component. What about the magnitude? This angle is 40 degree. So this is going to be cos. This is equal to 15 cos 40. So the other one is sine, 15 sine 40. So these are the resolved components of 15 kilonewton acting at 40 degrees and pointed towards O. So this is example 2. One more case. Say a force 20 Newton acting at 60 degrees with vertical, with this side, 60 degrees with vertical side. First of all, let us mark the directions of components. This force is away from O or outward from O. So the component should also be outward. This is Fx. This should also be outward. This is Fy. So these are the directions. Hope there is no doubt in that. What about the magnitude? This angle is 60 degree. Angle with y-axis is 60 degree. So this component will be cos 60. So Fy will be 20 cos 60. So that the other component will be 20 sin 60. Okay, I'll repeat once again. The force 20 Newton is acting outward. So Fx and Fy both are outward directions. The angle with y-axis is 60 degree. So this component is going to be cos. Angle from this side. So that component is cos. The opposite one is sin. The same example, it can also be put in another way. The same thing, this 20 kilonewton load, 20 Newton at 60 degrees with vertical is given in question. So the one student, the first student, he attempted it and he has written like this. That is right. Next, if you want, in some textbooks or some teachers teach it like this. If this is 20 Newton making an angle 60 degrees with vertical, they will always convert it to the angle with horizontal. If this is 60, this remaining angle is going to be 90 minus 60, 30 degree. The angle with vertical is converted into angle with horizontal. So now the angle is 30 degrees with horizontal. Both are one and the same. Now you resolve it. Resolve. The force is away from the joint. So the components are away, outward, outward. This is 30 degrees. So the component will be cos 20 cos 30. This will be 20 sin 30. Check. This is 20 cos 60. What is cos 60? 0.5. So this is equal to 10. This also sin 30 is 0.5. So 20 sin 30 is also 10. 20 sin 60. Sin 60 is root 3 by 2. So 20 into root 3 by 2. 10 root 3. This is also cos 30 is root 3 by 2. So this is also 10 root 3. So whether you use this concept, angle from which side, that one is cos. Otherwise, if you want to make the angle with horizontal, you convert all the forces, measure the angle with horizontal, and then you can make use of it. Fx is equal to f cos 30. So these are the basic principle in resolution of a force. Now, when there are several forces, we have to resolve each force into x and y directions. And then we have to sum it together, all the x component together, sigma fx, and sum it all the forces y component together. So if you want to add them together, there should be a standard procedure for sign to be adopted. So the sign convention adopted is all forces components which are upward. All the components which are upward is taken as positive, and all the horizontal components which are towards right are taken as positive. That is, in the standard Cartesian coordinate system, x positive is towards right, y positive is towards up. So the first quadrant, this is called second quadrant, third quadrant, fourth quadrant. So if the component of force in the x direction is towards right, that will be taken as positive, and if the component of the force in the y direction, if it is up, that will be taken as positive. All other things vice versa. Then we add all the force components in the x direction together, and we'll find out sigma fx, sum of all horizontal components of forces. Similarly, we will find out sigma fy, sum of all vertical components. Then the resultant is given by, you find out the sum of all the horizontal components, sum of all the vertical components. So these two are mutually perpendicular. This is sigma fx, sum of all the horizontal forces put together. The sum of all the vertical forces put together, sigma fy. Then these two are mutually perpendicular to each other. And the resultant, this is the resultant R, and R is given by square root of sigma fx square, fx the whole square, plus sigma fy. Square root of sigma fx the whole square plus sigma fy the whole square will give you the magnitude of the resultant. And resultant is also a force, single force, replacing all the other forces. Direction is very important. So the angle with the resultant makes with x direction, theta. Tan theta is given by Opposite side is sigma Fy. This is also sigma Fy. Sigma Fy divided by sigma Fx will give you the inclination of the resultant with the x coordinate direction or the horizontal direction. So this is the total sum of finding out the resultant of a system of coplanar concurrent forces. Now we will illustrate it with the help of a numerical example.